Hello pre-calculus students, we are going to work today with polar equations and rectangular equations. So we worked with coordinates before, now we want to work with equations of polar graphs and rectangular graphs and be able to convert them back and forth. So the directions here say convert the following polar equations expressed in terms of r, the radius, and theta to a single rectangular equation expressed in terms of x and y, identify the graph of the resulting equation, and graph the polar equation to confirm. So we have here a graph of a polar equation, r equals 3 secant of theta, and we want to convert this into an equation that only has x and y in it. Okay? And so previously, we've been able to identify this type of conversion, that x is equal to r cosine of theta, and y is equal to r sine of theta. Okay? And if you want to know where this comes from, you got to go back and watch one of the earlier videos where we talk about polar coordinates. So this is something that's going to give us a base to start with. Now I can also extend this idea and I can say x squared plus y squared. So x squared here, if I square this, is going to give me r squared cosine squared of theta. If I want to square y, it's going to give me r squared sine squared of theta. And I can expand on this idea a little bit, factor out r squared, which leaves me with cosine squared plus sine squared. And if you remember from trig identities, cosine squared plus sine squared is just 1. So I'm left with r squared plus, x squared plus y squared equals r squared. And this is another way to convert between x, y to r and theta. Okay. And notice here, this is a little bit unique in the way that it eliminates theta altogether. It's just a relationship using r, x, and y. And so with that in mind, with these two methods of conversion, we can now begin our work. And we're going to start out with r equals 3 secant of theta. And again, our goal here is to write an equation that only has x and y in it. So the first thing I'm going to do is convert this 3 secant of theta to 3 over cosine of theta. Okay. And my goal is to get something that looks like r cosine theta or r sine theta or r squared, because if I can get one of these expressions, that'll allow me to convert it into x and y. So what I can do next is multiply both sides by cosine of theta. Okay, so multiply both sides by cosine of theta. And now I'll get r cosine of theta on one side. On the right side, cosine and cosine cancel. This gives me 3. And you can see here r cosine of theta is really equal to x. So that means x equals 3. And from our work in Algebra 1 and Algebra 2, we know that this is a vertical line through 3, 0. And I'm going to graph this on my TI-83 just to confirm. So you're going to go into, clear out all of this here, and go into the mode. Make sure that we are looking at polar mode, and then we're going to hit y equals, and we'll graph 3 divided by cosine of theta. For our window, we'll go between 0 and 2 pi. Whenever I have sine and cosine here, I usually like to go to between 0 and 2 pi. Theta step is 0.1, that's good, and I'll just keep this between -10, +10, just a standard window. And we'll hit graph. And you can see that has that draws a vertical line through 3, 0. Now, one thing that's worthy to note here is that we've never been able to graph a vertical line before because it's not a function. Okay, so this is something that's not a function in rectangular mode, but it is a function when we graph it in polar mode. So it's sometimes useful to switch back and forth, and we'll see with some of the more complicated examples. So let's continue. We have another problem here that is r equals -6 sine of theta. And once again, our goal is to somehow get one of these expressions, r sine theta, r cosine theta, or r squared into this function, because if we can do that, that'll allow us to convert it into rectangular form. So the first thing that I'm going to do here in this problem is just multiply both sides by r. So multiply both sides by r. So on the left side, I'm going to get r squared. And on the right side, I'm going to get negative 6r sine of theta. But r squared is really x squared plus y squared. And over here, I have r sine theta, which we know is really equal to y. So this tells me that the whole thing is equal to negative 6y. Now, I'm not quite done yet because I don't really know what this graph is supposed to be. So I'm going to keep working on this until I get something that I recognize. So I'm going to move 6y to the other side, and I get x squared plus y squared plus 6y equals 0. Now this might look familiar. You might have to turn back the pages a little bit, but in your notes. But this is something that's called completing the square. I want to turn this into a perfect square. I got y squared and 6y here, so I need to add 9 to both sides. And I'll talk a little bit about why we need to add 9 to both sides. But once I do that, this will allow me to factor this entire set here. When I factor this, I get y plus 3 squared equals 9. Okay. Now this graph right here looks a little more familiar to me. I know that this is a circle with a center at 0, negative 3, and a radius of 3. And I'm going to graph this on my TI-83 to confirm. So this is r equals negative 6 sine theta. That's the original graph that I'm typing in here. When you hit graph, you can see the graph come up. It's got a center at 0. You can see the center is going to appear on the y-axis, and it looks like it's going to have a radius of 3. Okay. Now back to this point here, how was I able to figure out that 9 is going to be what goes in there? So we get back to the situation of how do I know that this is really review of completing the square. Just I'll write a note here. Complete the square. Okay. And so I need some number in here, and this is in this term here, a in this case is 1, b here is 6, and c here is what's unknown. And I want some number that goes in here that'll allow me to complete the square. And you got to remember that this is b is always going to be, b over 2 squared is always going to be equal to c when you have a perfect square. Okay, so you take this number 6 divided by 2 and square it, and that'll give you your constant for c, which will allow you to factor. So it gives you y squared plus 6y plus 9. And if you factor this, you're going to get y plus 3 times y plus 3, or y plus 3 squared. Okay. Just a little bit of review. Okay. All right, let's go on and finish our last problem here, which says r equals 2 sine theta minus 4 cosine theta. Okay. And I'm going to do the same thing that I did in the previous problem, which is multiply both sides by r. And I could square both sides, that's possible, but that's going to end up leading me to a bigger mess on the right side here. So I'd rather just multiply everything, and by everything I mean you got to put parentheses around the entire right side of the equation multiplied by r. So on the left side I get r squared, on the right side I get 2r sine theta minus 4r cosine theta, because I have to distribute the r here. Okay. So now I can use my conversion. R squared is really x squared plus y squared. And here you see I have r sine theta, so that will give me 2y. And then I have r cosine theta, so that's going to give me negative 4x. I'm going to bring both of these terms to the left side of the equation here, so I get x squared plus y squared minus 2y plus 4x equals 0. And then I'm just going to realign this and put all my x's together, x squared plus 4x. And I'm going to leave a blank here because I need to complete the square, plus y squared minus 2y. And leave another blank here because I know I'm going to need to complete the square there as well. So you got to ask yourself, looking at our example here, c is always going to be b over 2 squared. So in this case, take 4 divided by 2, square it, you get 4. Here you take negative 2 divided by 2, gives you negative 1, square it, it's going to give you positive 1. And just remember, if I add something to one side, I have to add it to the other side as well. So I got to add 4 to one side and add 1 to the other side. So now this will give me x squared plus 4x plus 4 plus y squared minus 2y plus 1 equals 5. I'm going to factor this. It gives me x squared plus 2, this should be x plus 2 quantity squared, and y minus 1 quantity squared equals 5. So, and now I've succeeded. This is the rectangular equation, and it tells me that I have a circle with a center of negative 2, positive 1, and a radius equal to the square root of 5. And so there you have it, 3 examples of how we can convert polar equations into rectangular equations.